All right, welcome. In this explainer, we're going to break down what's really going on inside tools like ChatGPT. We're going to lift the hood and look at the core engine that makes it all possible.
So let's just dive right in with the big question. How in the world did AI get so good at, well, seeming to read our minds? It's not magic, I promise. It's a story about solving one of the oldest, biggest problems in AI, memory. You know, to really get what's happening now, we've got to look back. We have to start with a huge problem that held back older AI models for years, and that big nagging problem was memory, or more like a lack of it.
Think about it like this. When you or I read a really long, complicated sentence, our brains just naturally connect the dots from start to finish. But for these older AIs, nope. It was like the beginning of the sentence just vanished by the time they got to the end. And that was a massive barrier to understanding language in any meaningful way.
And the tech responsible for this memory problem? It was something called a recurrent neural network, or an RNN for short. See, it was built to look at things one after another in a line. But that created a huge bias toward whatever it just saw, making all that important stuff from the beginning just fade into the background. So the solution to this was just a total game changer. And what's so cool is that the idea didn't really come from computer science, but from how our brains work. And that idea, as simple as it sounds, was attention. So that was the big question, right? How do you teach a machine to focus on what's important, just like we do? It's that cocktail party effect you might have heard about. You're in a super noisy room, but you can zero in on one single conversation. That's what they wanted to give to AI. And here's how they did it, the attention mechanism. Instead of that slow one-by-one process where you just hope the context sticks around, this new method lets the model see the entire sentence all at once. And then, this is the clever part, it gives every single word an importance score so it can figure out which words are the most relevant for what it's trying to do.
Okay, and you can see just how powerful this is in action right here with something like machine translation. Look at this. To get the French word je, the model puts a whopping 94% of its attention on I. Makes sense, right? But then for the next word, T, look where it looks. It jumps all the way to the end of the English sentence, focusing 88% on you. And for M, it zips right back to the middle, locking onto love with a 95% score. It's not linear anymore. It's all about what's important no matter where it is in the sentence.
So this one idea, this attention thing, it wasn't just a small tweak. It was so huge that it became the literal building block for a brand new type of AI engine. An engine that's now running pretty much all of modern AI.
And this all came to a head in 2017. Researchers at Google dropped this bombshell paper with the title that was just so perfect and so bold. Attention is all you need. And yeah, they were right. This paper basically kicked off the whole revolution we're living through right now.
And that new architecture they proposed? It's called the transformer. You've probably heard of it. The absolute key to the transformer was that it completely ditched those old, slow, one-at-a-time RNNs. And in their place, it used this super-fast parallel self-attention, where every word could connect with every other word at the same time. This was the breakthrough that let us train these massive models on way more data than ever before.
And this timeline, man, it just shows you how incredibly fast everything happened. So you have the basic idea of attention popping up in 2014, just as a helper for the old models. 3 years later, bam, 2017, the Transformer paper makes it the main event. And then, just 1 year after that, OpenAI drops GPT-1, the very first generative pre-trained transformer. The race was on.
Okay, but here's the thing. Having one of these pre-trained transformers is just the starting line. It's an incredibly powerful generalist, but to really unlock its potential, you have to turn it into a specialist.
And this is a really important distinction to understand. On one hand, you've got your foundation model, like GPT-3. Think of it like a fresh university graduate. It's been trained on basically the whole internet, so it's got this huge, broad knowledge base. But then you have the task-specific model. This is more like a specialist doctor. It took that general knowledge and then trained intensely on one specific thing, like tutoring, to become an expert.
And there's a name for this process of creating a specialist. It's called fine-tuning. The whole idea is, why build a whole new AI from the ground up every time you need something done? That's crazy expensive. Instead, you just take one of these powerful pre-trained models and fine-tune it on a smaller, focused set of data.
And really the process itself is pretty straightforward. Step 1, you pick your base model.
Step 2, you put together a custom data set with examples of exactly what you want it to do. And Step 3, you just keep training it on that new data to nudge its skills in the right direction.
Okay, so what does all this tech talk mean for you, for the real world? Well, this isn't just theory. It's actively creating whole new skill sets and, yeah, whole new careers.
And this is where the rubber really meets the road for a lot of people. All the technology we just covered, it's created this explosion of new in-demand skills. Things like prompt engineering, actually fine-tuning these models, and something called LLOps. These are becoming critical skills in the job market right now.
And if you get good at these skills, you're looking at some really exciting new career paths. Companies are actively hiring for roles that didn't even really exist in this form a few years ago. Machine learning engineers who specialize in this, NLP specialists, even ethical AI advocates. All of it is built on the back of the Transformer.
So if there's one thing to take away from all this, it's that a single powerful idea, just teaching a machine how to pay attention, is what unlocked everything we see today. And that brings us to a really big final thought. Now that we've successfully built machines that can focus so incredibly well, the most important question isn't about the technology anymore. It's about us. What do we want to point all this attention at next?